I'd like to look at a couple of questions where what we're trying to do is substitute either a number or a algebraic expression inside of a function. So we might be faced with having been given a function. For example, it may look like this. And we're asked to evaluate this function perhaps at a number. For example, someone might ask, what is f evaluated at -3? Okay, well this expression or rule or formula is actually telling us how to evaluate f at any number. And in particular, if I wanted to figure out what happens at -3, then everywhere that I see an x, I could mentally erase it and replace it with the number 3. So that's what we're going to do. So f evaluated at -3 is equal to -3 plus 1 divided by -3 minus 1. Now our job is to make this look nicer and simplify it. Okay, so the top, yeah, it's -2. The bottom, okay, -4. And then there's a couple of reductions I can make. So, you know, -1 divided by -1 is the same as the number 1. So a short way of saying that is these minus signs cancel. But really what you're doing is multiplying the top and bottom by -1. Then you got 2/4. That's the same as 1/2. And so the take-home message here is that when you substitute a x value of -3, so x's are usually called your input variables. Sometimes they're known as the independent variable. And in math classes, they're invariably, you know, represented by the letter x. But of course, in practice, you'll be dealing with some situation where you have a natural variable like time, for example. You may not want to use the letter x. You might use the letter t for that. But generally in math classes, we just kind of constantly use the letter x for the input. And then f of x, the output, we have determined here that the output associated to -3 is the number 1/2. This would be your y value associated to this x value. Now in the next example, what I'd like to do is what happens when I'm not evaluating f at a number, but in fact at another algebraic expression. For example, what if we were faced with this situation? F of x is, let's say, x squared minus 2x. And then the question is, what is f of x plus 1? Okay, slightly more challenging. Same idea, though. Everywhere that I see the letter x, I mentally remove it, and I put in its place x plus 1. Okay, so I have x squared, but I want to no longer evaluate this function at x. I want to evaluate it at this thing, x plus 1. So I'm very careful to just absolutely replace. I had something squared, it was x squared. Now I have something squared, it's x plus 1 squared. And the same thing here. I see an x. I know I'm supposed to replace that with x plus 1. And you can see how powerful the brackets are, okay, to make sure it's correct. Now I'm in the situation of maybe expanding this and simplifying, and that's not too bad, okay? So what does x plus 1 squared really mean? It means x plus 1 times x plus 1. It might be useful to actually write that. And then you can distribute the x and the 1 through both terms, and it looks like this. X squared, x times 1 is x. This 1 times x is another x. This 1 times 1 is 1. Here the minus 2 needs to be distributed for each of these two terms. Minus 2x, minus 2. Now we're in the collecting stage. All of my x squareds go together. There's just this guy. All of my x's go together. X plus x is 2x, minus 2x is 0. So there are no x terms. Plus 1 minus 2 is minus 1. So this was substituting numbers and short expressions into functions.